So my name is Martin Kučera, and I did my bachelor here at CTU a few years ago. And then I studied in Switzerland, and I got the opportunity to do my master's thesis in the lab at EPFL, which kind of created Scala, the programming language. So today, I want to tell you something about the thesis that I did, and like in general, Scala and type safety and databases. And before I start with that, I want to just share like 3 moments, I guess, in the past few years that kind of led me there, and hopefully maybe you'll find them interesting. So it all started when I was in the 2nd year at CTU, and I was about to go for an exchange in Singapore. And because I was going there, I knew that I was going to extend my studies for 1 year. And so I didn't necessarily have to take all the courses that I was supposed to in that year before. And so I was checking the survey, the student survey, where they tell you like how all the different courses are. And I was looking at the OOP course, and it had really, really bad reviews. Like it was one of the worst courses according to the survey. And the reason was they were teaching like some weird, I think it was called Faro. It was like some graphical interface for small talk, and it apparently didn't really work. And after I read those reviews, I was like, I don't want to take that course. So I didn't take it, and I thought like, I'll go to Singapore and maybe they'll improve it within that year, and then when I come back, it'll be better. And surprise, this actually happened the year I came back. They completely changed the course, they changed the teachers, they changed the language to Scala. And this is how I kind of learned, this was the first time that I encountered Scala. And this was probably the only reason that I ever went further to work with it. So this is kind of the first moment that I wanted to share. And there's a takeaway in Czech, but it says that the FIT survey works. So I would like to maybe encourage you at this point, at the end of the semester, fill out the survey, because they really care and they changed the stuff that's wrong. Okay, so after I came back from Singapore, I kind of started thinking about, let's say, what to do next, because I was about to do my bachelor's thesis, and I wasn't sure that I wanted to stay here in Prague for my master. I had a lot of friends going away, going abroad, and I thought maybe I would like to try the same. And I thought, let's just for fun, let's try to apply to like one of the top universities. So I actually wasn't that sure at that point like which ones they are, so I checked the QS ranking. I don't know if you can see it well, but it's like the first, 13, I guess. And I looked at the ranking, and I was like, let's try one of them. So let's try maybe the first one, MIT. Well, that didn't work out because I found out that they don't really offer master's courses unless you did your bachelor there as well or something like that. So I crossed it out. And then I went further down the ranking, and I kind of crossed a few more. I basically crossed out all the American universities because of either similar reasons to this one, or I just thought like the application process was really complicated, and I didn't think I had the time to do it properly and to get a good chance to be accepted. So I crossed those out. Then I crossed also Singapore out because I had just come back from Singapore and I kind of wanted to try something new. Then there is Harvard and Cambridge, which I also crossed out because their master is only for 1 year. And I thought, if I just go there for 1 year, like before I kind of get used to everything, it's already done, so it's maybe too short. And then the next 2 are EPFL and ETH, which are 2 Swiss universities, and I looked kind of further into them, and I found out that according to what they write online, they're pretty similar, and I was a bit more fond of ETH because it's in the German part of Switzerland, and I already had studied German in my high school, so I knew a bit of German, and so it just seemed like a better fit, so I sent an application there. And then I kind of wanted to send applications to like a bunch of other universities, both in Prague and around the world. And this was really just kind of to say that I tried to apply to one of those in the top 10. So then I pretty much forgot about it, but then a few months later, I got an acceptance letter. And so I felt like, okay, I guess let's go. And here's like the second takeaway, which says something like, try it even if the chance to succeed is very low, because you never know what can happen. And then I guess motivated by this, I also tried to apply for this Bacala Foundation scholarship, because Switzerland is pretty expensive, right? And this one, well, didn't work out. So the email that's showing here, it basically says like, sorry to inform you that we rejected your application. So yeah, too bad, I guess, it happens. Well, guess what? Like 1 month later, I got another email. And they said like, oh, you know, someone else who was supposed to get the scholarship refused in the end. They changed their mind or whatever. They didn't want to study abroad anymore. And so they said like, do you want to do an interview and have a chance to get it still? So I said yes, and then I did the interview and I got the scholarship as well. So yeah, just sometimes, you know, good things happen when you don't expect them. So that was it, and then I went to Zurich to ETH, and then I'm kind of gonna gracefully skip the 2 years at ETH, because even though they were very interesting and I could say a lot of things about like comparing ETH to CTU, it's not really the topic of this lecture, but if you're really interested, maybe we can talk about it later at the end. But what I wanted to share is that at the end of my studies, when I was supposed to do my master's thesis, I didn't really know what to do. And I had studied theoretical computer science at ETH, so I wasn't even doing much coding. And I actually wanted to do something theoretical for the thesis as well. But the problem was that like all the professors that I really wanted to work with at ETH, they were actually from the Department of Mathematics and not computer science. And when I was talking to them, they were like, well, we kind of really want a mathematician, not a computer scientist, to work with us. So they were all rejecting me. And so I was kind of desperate, and I couldn't find a cool project for my thesis. And then I was talking to a friend of mine at Oracle Labs, where I was also working at the time. And he was like, well, didn't you mention that you really liked Scala? And I was like, yeah, I did mention that. And then he said, well, why don't you go to do your thesis with Martin Odersky? And Martin Odersky, that's the person who created Scala, and he's at EPFL, so that's the other Swiss university than the one that I was at, but not so far, I guess. But I thought, like, what kind of crazy idea is this? Like, I don't really know much about Scala. I took this bachelor course, and then I didn't do anything with it for years. And I don't know anything about compilers, and I don't know anything about programming languages. Like, all I've been doing here is like graph theory. So I was like, maybe no. But then I went home, and I kept thinking about it. And in the evening, I was like, I'm just gonna send him an email. Like, what can go wrong? He's not gonna reply anyway. So I wrote this like 5-sentence email, and then I spent hours just looking at it and being too afraid to hit the send button. But then maybe around midnight, I was like already too sleepy, and I just said, okay, I'll send it and let's see what happens. And the thing that happened is that he replied and he said, okay, let's have a Zoom call. And we had a Zoom call, and then he just like kept speaking for an hour about all the projects that they're doing and what I could do, how I could help them. And then he kind of asked what I was interested in, and I said, well, I don't know much about Scala, but I like it, and I also like databases. And so he thought, like, actually, we've had this interesting project in mind. You could make a new database library for Scala. And I was like, okay, let's do that. So this is how I got to EPFL. And here's the last takeaway that I wanted to share, which is, don't be afraid to ask. So this is, I guess, the most important thing that I learned through this. And then I went to EPFL. So here you see the building on the left side at EPFL where Scala is being made. I actually had an office like right in this window at the top floor, the one that's like only half of it is visible on the right side. And on the right, you see a logo of Scala. And if you see some similarity between the left and the right, then that's because the Scala logo is actually like inspired by this staircase. So yeah, it's just something interesting. And yeah, I had a great experience at EPFL. I got to basically work with all the people in the lab. Whenever I had some problem, I could talk directly to the people who are working on this specific feature of the language. So it was an amazing opportunity. I would encourage anyone who's maybe interested in that to do the same thing and write either to Martin Kučera or to whoever like the person is that's doing whatever you're interested in, and you never know what they reply. But now, I think it's time to start talking about the more technical stuff. So, first of all, I want to briefly explain what I mean when I talk about type safety. So here you see some really simple function in Python. It's called add numbers, and it adds the numbers together. So who of you thinks that this function is correct? No one? I see a few nods. I think it's correct. So I would say let's ship it to the customer and see what happens. Okay. We shipped it to the customer. They're happy. They try to run it with this input, and it fails, of course. It fails in runtime, which kind of sucks, right? Who would have expected that? So this is something that can easily happen in Python, but it can also happen in programming languages. And when I say that something is type safe, what I mean by that is hopefully it's preventing this kind of errors. So for example, let's see a very similar code in Java. It looks much uglier, right? But the important difference is that here we explicitly said that these two inputs are of type integer. And so if the client tries to do the same thing now, it's not going to compile. And so they will find out about this bug even before they, let's say, push it to their production server, and so they can fix the error and then push the correct code without having any issues. So this is really a toy example. Maybe it's hard to imagine how something similar could happen in practice, but I think it's important to think about. And here, just to really stress the difference. So in Python, we don't have that, right? In Python, we just run the program itself. But if we talk about compiled languages, then we really, this distinction is really important. So we first compile, and then we talk about whatever happens at that point, we call compile time. And then once we get the result of that, some executable, either binary if it's C or C++, or a jar file if it's a Java or any similar JVM language. And then once we run that jar, this is called runtime, and then this produces some output. And this distinction is probably very trivial, but it can become more confusing later when you actually try to affect what happens at compile time, which you usually don't, but in this lecture we will kind of be doing that. So here is just a bit more, another similar example of what can go wrong in runtime, but can be prevented in compile time. So this is actually from the domain where I work currently. So I work at a company called Informatické, which does algorithmic trading. And so we deal with some accounts, which are accounts on, let's say, some exchange where we can trade. And let's say the account just has some ID and then a currency that it trades in. And then we have some agents. Agents are just, either humans or computers that trade in some way, they decide what's going to be traded where. And then let's say we have this order service through which we can place an order. And this order service, this place order function takes an account ID, an agent ID, and then whatever other parameters, probably a lot of them. But now let's imagine we're somewhere else in our code, And we're going to try to run this place order. So, how are the parameters again? Was it first agent ID, then account ID, or the other way around? I don't really remember. So, yeah, it was actually the other way. And if I run this, I'm not going to get a compilation error because they're both of type string. So everything kind of works, right? But then I will probably get a runtime error because I will try to, store something in a database and I will use the wrong ID here. In the worst case, I won't even get a runtime error because actually both of these IDs might exist. They just represent a completely different account and a completely different agent than I wanted. So it will seem to work, but the program will actually do something different than what I intended. So what people sometimes do to prevent this kind of issue is that they create these artificial wrapper classes, account ID and agent ID. And then they use these instead of using the string. And through that, they kind of force the type system of the language to give them this compile time error if they do something wrong, right? So now, if, again, I call the same function with just the wrong order, the compiler will actually tell me that I did something wrong, and then I can fix it before pushing it to production. So, yeah, this was just my attempt to show some more real-life situation where type safety can help you. Okay, so now another quick question. How many of you have used Scala before? Okay, is there anyone who hasn't used Scala is maybe a better question. Okay, have you used Kotlin or Java? Yes? Okay, so then at least I guess that will help. And I will just quickly introduce a few key things in Scala, and by key things I mean not necessarily features, but rather aspects that change the way you think about this language compared to other languages. So one of them is type inference. So, and here again now from now on we will only see Scala code. So here's again the same function, add numbers. And you might say it was nicer to write it in Python where you didn't have to write out any of those types, so it was much less writing. So the nice thing is in Scala is you actually only need to write them in certain places. So you need to write them here, for example, for the parameters of the function. But let's say here, for the type of the variable, you actually don't have to write it. You can just write it like this, and it will work perfectly, because the language has this type inference feature, which kind of knows, okay, I called add numbers, and the result type of that is an integer, so I know that result is also of type integer. Actually, you don't have to even write the int here. It will also infer that, but this is already some place that I like to write the type, because, again, it gives you some guarantee that if the body of the function does something different than kind of the signature suggests, the compiler will tell you and maybe prevent some bugs. But it's still a really useful thing that type inference works. It works in much more complicated places than this one, and it can help you save a lot of time. Okay. So another important thing is that everything in Scala is an expression. So you probably know this distinction between statement and expression, where statement is something that doesn't have any value, and expression is anything that has a value. So in Scala, everything is an expression, even the things that you wouldn't expect to be an expression. So a block of code, the value of it is just whatever is last in that block. And if the last thing in the block of code is an if-else statement, then the value is either this, if we fall in the if branch, or this, if we fall in the else branch. And then, again, we see that I didn't write any type here, because the type inference actually cracked, even in this case, what the correct type is. So what it did is it looked at this if-else condition, and then it looked inside, and it saw that there is a string here, and there is also a string here. So the overall type of greeting, in whatever case, if we go into the if or else branch, it's always going to be string. So it knows that greeting is of type string. So it's kind of interesting how they actually managed to do that. It's not obvious that everything can always have a value. In particular, like if you have a function that doesn't return anything, then how can it be an expression, right? So for that, they actually created a new special type, this unit here, which is like among the basic types, and it just means like no value. So if function doesn't return anything, then it actually still returns an instance of this unit. And then maybe another weird case where it's not clear how it can be an expression is throwing an exception. So you can throw an exception anywhere in the code, right? And if Scala thinks it's an expression, it has some value, like what is the type of that value? So Scala has this weird type called nothing, which is a type that kind of extends from everything. And so you can throw new exception anywhere in the code, and will always kind of think that this is okay because it's a subtype of whatever you wanted to put it in. So for example, here, I read some string input, and then I say if all the characters of that input are digits, then I can convert it to int, and otherwise I just throw a new exception. And again, the type checker will just see, okay, here is an integer, and here is nothing, which is subtype of integer, so this will work. Also, in Scala, everything is an object. So here I have an example where I say, like, number is -10, then I can call number.sign, because it's an object, and it has this method sign, which gives me -1 or +1 based on the sign of the number. Even adding two numbers, this plus is actually nothing special in Scala. It's just a method of this object, of this instance of integer, right? So calling 1 + 2 is actually the same as calling 1.plus with the parameter 2. And even functions are objects. So here we have a function that takes x and y, right? Again, returns x plus y. And here I wrote the type explicitly. And the type of this of this object is function2, and then it has some generic like type parameters. So again, like if you're used to, let's say, Java, then this would be the sharp like less than less than and greater than signs, with like the return type and then the parameter types. And then calling this function like this is, again, just syntactic sugar for calling f.apply, so the apply method on this f object. And then everything is also a function. So yeah, for example, here I have some map, which maps numbers to their like string values. And then this map has this apply method implemented. So if I call digit to text1, then I get the value that maps 1 to 1. Yeah. Here, basically the same thing. I'm just showing how I can put this function when I'm mapping. So I take this number, and I want to get the string kind of representation of it. So I map it. I first convert it to string, then I convert each of the characters to a digit, and then I map the digits to their text representation using this map digits to text, which, right? So map takes a function. But digit to text is an object, but it's also a function. Singleton objects is just something that we're going to use later. It's not really like a core Scala feature, but I just wanted to mention that they're there. So if I create like an object like this, what it actually does is it will create a class, and then it will create an instance of that class that I can access through the name of the object. And there's kind of no way to create another instance of that class. Okay. So this is kind of the Scala crash course, I guess all the important stuff that we'll need. And now we can talk about databases. So here is like a simple database that I will be giving some examples on. And the database has basically 3 entities: artists, releases, and tracks, right? So it's a music database. And we see that every artist, so every release has some artists that participated on creating it. There could be one or there could be many. And then every release has some tracks that kind of belong to that release. So that's it, just a really simple database. And now I'm gonna show like some problems that can occur when talking to databases, which might be a bit surprising because like we're using Scala, so now that's a pretty type-safe language, everything should be fine. But suddenly when we start talking to databases, then things can go wrong again. And I'm just gonna use this like bare Java library, which you probably wouldn't do in practice because it has a lot of problems with like not such a nice API and like maybe security issues with like SQL injection. But to just showcase the type safety issues, it should be fine. So the first kind of problems that can occur is problems on the database side. So we send some query to the database, and the database itself doesn't know what to do with that query. And now, of course, because it's kind of, everything happens in runtime, there's no way to prevent this at compile time, at least when we do it like this. Because for Scala, this query is just a string, so obviously there's nothing wrong about it. But when we run it like this, well, we get a runtime exception because the database doesn't know how to compare name, which is of type string, with the integer 7. So this is one kind of problems. And then another kind of problem is when actually everything works fine on the database side, but once we get the result back, we kind of treat it in a wrong way. So here we select title and position from the tracks table, and then we just like iterate over the results, and we try to get the title and the position and print them out. And again, this seems correct, right? So when we run this, we get this exception, which says bad value for type int a. So turns out that actually this position, and like this is something that actually like happened to me when I was playing with this database. If you look into the records there, position is basically always a number because it tells you like the order of the tracks on the release. But it also has some LP records in the database. And the LP records, they have two sides, right? And the sides are usually distinguished by letters A and B. So this is something surprising that like is hard to expect. So again, you have to be careful how you handle that. And then a very similar problem here, like basically the same code, but you see I change now. I select position as a string because I don't know what might be there. But I also try to get this duration, which I didn't select. So obviously that's a problem, and I get a similar error. And again, this is something that like it's not gonna happen if I see the query right here, but maybe this is called from some function, and then I process the result somewhere else, and I don't remember anymore what I selected. And I'd be really happy if the compiler told me that I'm doing something wrong. Okay, so here I just like sketched some API, like what I would like my SQL library to look like if I didn't care about anything like how it works internally. So this is kind of a like natural way to process data in Scala, let's say. I would call some function that tells me find all tracks, and then I could like filter through it. I could say that I only want tracks whose release ID is 10 or 12. I could say I want the title to start with the string hello. I could sort by title. Then I would get all the tracks, and then I could print them out like this. So this would be really nice, but it kind of hides some difficulties that we might encounter when implementing this. So first, yeah, I mean, we could really have this function select all the tracks in the database, but then there might be like millions of them. So maybe they wouldn't even fit in the memory. So that's not a really good approach. So generally, what we want to do is somehow look at this whole query and generate an SQL query kind of from this Scala functional code so that all the filtering happens on the database side, and then we only get back the final result. This is maybe still doable, but what is more complicated is like what happens to the result afterwards. How do we, so here like I'm printing the track.release.title. So what does this mean? Like, should I have selected with some join so that I also have the releases from that track? But I didn't really know at this point when I was kind of getting the instructions about the query, whether I should make this join or not. And here it's too late. So maybe maybe you've heard of like object relational mapping. So what these libraries would typically do is at this point when we try to access this, like run some additional queries. But then again, we get some issues with performance, right? Because we're running more queries than maybe we necessarily had to. Also, maybe we didn't want to select all the columns of the database, or of the table, I mean. But if we didn't select all of them and we're representing these tracks with some objects, then what do we put in the fields that we defined in the corresponding class if we didn't select them? So these are issues that are kind of hidden away from this API, but we still need to care about them. And because of that, the API is going to look a bit different, but still kind of similar, actually, to what I showed here. And I'm going to show it to you now. So first of all, we have to tell the library how the schema of the database looks like, so that it can do all the nice type checking for us. And the way we do it is we create one object for each table in the database, and we give some fields to the object that correspond to columns in the database. So like you see here that for the column ID, I created a field ID, which is of type column int, and it's the primary key. And the same for title, I have a column string, and so on. I even skipped some because it wouldn't fit on the screen. We do the same thing for all the tables. And then besides that, we also give some extra information, which is the relationships between the tables. So here I said that I have this relationship, which like for every release, I have its tracks, which is a one-to-many relationships, and it refers to the table tracks, and kind of the opposite like field is tracks.release. And then also on the tracks, you see that I have a release, which is the opposite relation. So it's many to one, not one to many. And it points to releases, and it points through this release ID column. So this I would also do for the other two tables that I didn't show here, but it's completely analogical. And then I can run queries. So here's an example. You see that it's very similar to what I showed before. It's also doing pretty much the same thing. So it's selecting from tracks, and then it's filtering. Again, it says release ID should be either 10 or 12. It says the title should start with hello. It should be sorted by the title. And then at the end, we also do some mapping. So we say that we actually only want to select the track title and the release title. And then we call the track title just track, and we call the release title release. And then finally, we run execute. So this one is very different. We didn't see that before. But this kind of tells the library, OK, now generate the SQL query and run it. And then once we do that, we can iterate over the results. And the results are kind of flattened. So actually, this row is now something that has two fields, track and release, that we can access. If I didn't call this map, then what I would get is like all the fields of tracks, but I would never have this like relational or object. I should say object-oriented structure that like the ORMs give you. So I couldn't call track.release in this result because this really like brings so many complications that I think it's not worth it. So instead, what StyleQ does is, like, if you want to select something across multiple tables, you always have to do this mapping, and you kind of say how the flattened structure should look like. You never have this like nested stuff. Okay. if maybe this looked a bit confusing, I'm gonna now show something similar, but in live coding. So let's hope that it works. Right. Okay. So let's make it bigger. Can you see it? Hope so. So first of all, here I just have like exactly the same schema defined that I showed you, except for that all the columns are here, even the ones that I left out, and also the two tables that I didn't show are here. Then I just connect to the database, and now I can run my queries. So here, I wrote some comments just to tell me what I actually wanted to do. So here it says, list titles of all releases by Radiohead that contain less than 5 tracks and sort them in alphabetical order. So let's try to do that. I'll create some val queue, let's call it. And I'll say from releases. And now I'll filter. And for some reason, VS Code is really slow, but I'm intentionally waiting for the suggestions because I want you to see that it knows what's there. So I can say that the artist of that release, there should exist one among them whose name is Radiohead. Okay. And then I can also filter, and I want that they have less than 5 tracks. So tracks.count is less than 5. Then I map to the title. And then I sort it. Okay. So now let's say I execute this query. I call queue.execute. Then I can maybe print the results. So I can say like for each release. And I just print it. So you can see here that the release is of type string. Not surprising, I hope. And if I run it, and now I'm praying that it works, it's probably going to take a while because this database is really pretty big and it doesn't have any indexes on it. But at some point, it should print out a few releases. And if it doesn't work, I will maybe run it through the terminal because, here it is. And you can see that some of them are duplicated, but this is actually not the fault of my library. This is the fault of the database because for some reason it has duplicates. So if I wanted to convince you that this is true, maybe I could, instead of just mapping to the titles, I could map to more than one thing. Release the title, maybe also release.id, so that I can show that these are actually distinct. But now also the cool thing that you can notice is that actually this release now is not a string anymore. It has 2 fields now, title and ID, exactly as I wanted. So now I could print release ID and release title. Oh yeah, thanks. So now if I run it, you can see that all these rows with the same value actually have a different ID. So yeah, it's just a weird database. Are there any questions about this? Maybe some adjustments that you would like to do to the query? Maybe just to show you like how this is really changing dynamically. I think it's really cool. Like if I rename this title like this, I say actually I want to call it just T. Then you see suddenly that VS Code is telling me I have an error here and says value title is not a member of result anymore because result just has T and then it has ID. And so this is actually not just VS Code, but that's the compiler itself telling it to me. So if I try to run it now like this, then it should fail. And I was expecting that now it would happen more quickly. So maybe I can just show you in the terminal. Oops. It's too dark? Oh, I'm sorry. Maybe if is it better when I select it like this? So yeah, it's like it's really the same thing that VS Code was telling me. It's just, you know, I'm trying to print out the release.title, but it doesn't exist. So yeah, this is how the library works. And now I can maybe tell you a bit about how it works on the inside. So here I'm showing you like the most central like class within the library. It's called Query Builder, and I guess already seeing it, you can guess what it's doing. So it's representing the SQL query that we want to run, and every time we call some method on it, like we saw map, filter, sort by, and similar. Again, this is like shortened. I don't have everything in here. Every time we call one of these methods, it returns a new instance of this query builder with one of these fields modified. And again, these fields correspond to parts of the SQL query. So there's the from, where, and the order by, I guess, are obvious. The scope is basically the select clause of the query. But I intentionally didn't call it select. I call it scope because it has a bit more like meaning within the library. So you can see that the type of this scope is S, and this S is like a generic type parameter of the query builder. So I try to always maintain what I'm selecting not only as a runtime value within the query builder, but also within the type of the query builder itself. This will help me to later do all the type checking with the values that it kind of returns. Right? Maybe I can. Oh, actually, I think I have a slide about that later. So yeah, this is kind of the important thing to notice here at this point. And it's not so important what scope specifically is, but what is important to know for now is that it's some type that represents what I'm selecting, and we will see later what it is. And in order to do that, we need to dive a bit deeper into some more advanced Scala features. Specifically, there is this thing called structural types. It's new in Scala 3, and it didn't used to be there before. And what this is doing is kind of trying to do something similar that the dynamic languages like Python or PHP have. So there's this weird class called selectable, and if I extend from it, I'm basically telling Scala that I'm gonna have this select dynamic method, and this method should be called whenever I try to access a field of this record which doesn't exist. So if I try to access a field on this record and it doesn't exist, it will call the select dynamic method. It will give me the name of that field as a parameter, and then whatever I return from this method, it will take it as the value of that field that I try to access. So this is really something that, like, in a dynamic language, it makes sense how this works, right? Because, yeah, everything just kind of happens at runtime. There is no type checking, no anything. But how can this work in Scala, right? So here, just an example. So I create an instance of person. I give it a map where I say the name is Emma and the age is 42. And then, according to what I said, I should just be able to print person.name. It should work. Actually, it's not gonna work just like this, because what I said about this calling select dynamic, this is something that happens in runtime. But Scala is never even gonna let me run this program because it will fail at compile time, because of course person doesn't have a name. But there's a way to kind of cheat the compiler into thinking that there is actually a name. And the way to do it is through casting. So I cast this record, and I say, oh, this is actually not just a record. This is an instance of a record, and at the same time, right, this ampersand is like intersection. At the same time, it's some object which has these two fields, name and age. And name is of type string, and age is of type int. And by this, I kind of told the compiler that those fields are there, even though it thought they weren't. If I did that, it's going to listen to me, it's going to let me compile, because now it sees, OK, there's this name of type string. They told me that is there. So this is how I can cheat the compiler into thinking that it's there. And then when I actually try to run the code like this, it would work, and it would print out Emma. Now, of course, you didn't see me writing this S instance off anywhere when I was using the library. And this is because it happens automatically, like the library does that for me. But how does it do that, right? Like this is not clear how to do it, because if I just do it in some function, then it will happen at runtime, but I need this to happen at compile time. So now we go back to the little diagram that I showed earlier. Anything that a function does, it happens too late. It happens only when I run the program. But I need my library to do something while the program is being compiled to kind of insert this in here. So yeah, maybe just now I can go back to the type of the query builder, and I'll show you what we actually see, like what the compiler sees when we do the different steps of running the queries. So if I just wrote that I want to select from releases, then this would actually give me an instance of query builder, and it would say that this type parameter of it is something that I called table scope. Table scope just says like I'm selecting select star from table, and then releases.type. This is the type of the object releases. But now if I called map on it, and I said I only want to select release ID and release title, the type of query builder would change, and suddenly you see something similar to what I showed you before with these structural types. So the type now is tuple scope, not table scope. That's because this, what I returned here, is a tuple, right? But I also told the compiler, at the same time, it's an object that has a field title and a field ID. And those have like some weird types. That's not so important for now. But the important thing is I convinced the compiler that this stuff is there, and it's stored in the type of the query builder. And now if I run the query, I get back the result. And again, the result is going to have that information in itself. So if I run the query, the type of the result is going to be an iterator over some class result. But that class also, at the same time, is an object which has a field ID and a field title. Okay, so how do we do that? How do we convince the compiler to have that in the type? So we need to do something at the compile time. And now, like maybe just a few words about how the compiler actually works. So it represents our program as some abstract syntax tree. Maybe you heard about that before. This is just a very simple example where we have like a program that does like 1 + 2 × 3. The AST of it could look like this. So, you know, it's some tree that has the plus and then the 1 and then times 2 and 3. Every program can be represented like that, although the tree would be much bigger. And now what the compiler does is it first reads the program as a text, and then it parses it into this tree, and then it keeps kind of transforming that tree over and over again. So it has several phases, and each time it goes through that tree, and it transforms some of the nodes into some other nodes. And in the end, it has something that resembles more like the Java bytecode rather than the original source code. And then in the final phase, it prints out kind of the bytecode instead of this AST again. And so what we want to do is tell the compiler that in some phase, it should do some extra modifications to this AST. And the most simple modification that we can do is called inline functions. So the phase in the compiler would be called inlining. And how it works is we define a function with just this like one special keyword inline before it. And when we try to compile this, then let's say we just call the function parameter with a number 5. When the compiler goes into this inlining phase, it will actually replace the AST that represents this by the AST that represents this. So it will just take the content of this function and put it here instead of having the function call there. So this is like the first like baby step in which we told the compiler to do something at compile time instead of doing it at runtime. And now from here, it's actually not too far to do something more clever. So now we just want to, instead of just pasting something from here to here, we want to actually execute our own code. And what this is called in Scala is macros. So again, you've probably heard of macros in different contexts. In C, they are something very low level that like works with just replacing strings. But in the Scala context, this actually works with the AST. So here, there's a lot of like scary-looking boilerplate code that you need to write when you want to work with macros. But kind of the most important parts of it are we defined again an inline function. So this just says we have some function which takes a parameter, and then whatever the body of the function is will be put into where we call the function from. And the difference here is that the body of the function is not actually just like some code that will be put there, but this weird syntax dollar and curly bracket. It says, okay, we're gonna invoke our own code here that will get executed before pasting. So we will not actually paste this, but we'll call this function showImpl, and we'll paste whatever expression, whatever AST this function returns. And now, like in my toy example, this function actually doesn't do anything fancy. It just returns the parameter that it got, but it also just prints it out so that we can see what it is that the compiler sees. Right? So so actually, like if in my code now I called macro.show 5.0, after this phase when the macros are executed, this would actually be like completely the same as if we just wrote 5.0. But because we called the macro instead, it will also, during compilation, print out what the compiler saw. So we can have a look. So actually, this one would print something like this. So it just says there was a literal constant 5.0. We could try it with some more interesting code. So here we just say macro.show, and then we give it some variable, and then +2. So what did the compiler see? It saw this. Already a bit more complicated. So here is something called apply, which basically says we want to call a function, and then it has two parameters. First is the function that we want to call, and second is a list of parameters. So the function that we want to call, it says you can get it by selecting from the identifier x the method plus. So this is what I mentioned earlier, right? So plus is just a method on the integer class. And then, again, the parameter list, it just has one parameter, which is the literal constant 2. So, yeah, I hope this still makes sense. And now even a more complicated example. Let's see what happens if I give it this map that we saw earlier. Then it prints out this, right? This is a mess, right? There's no need to try to like understand what all of this is as a human. But I just wanted to point out that you can actually find all the like important information in here. If you just like look with Control F or something, you'll find out that here is some literal constant name, right? That's this name. Then there's an arrow, and then there's a literal constant Emma, so this is this Emma. And then somewhere later on, I don't see it now, but somewhere here is an H, here, right? And then again there's an arrow, and then somewhere is 42 here. And so in this macro, you can just take whatever parameter you want. You can look at it as the compiler looks at it, create something new, and then give it back. And specifically what you can give back is the query builder cast it so that it has all the special like fields that we want to select in its type. Right? So this is, again, like zoom into the map function. What the map function does is actually it invokes some macro. The macro will look at the lambda function that this map gets. It will look at what it returns, take it, put it back into the type of the query builder, right? So this is the code that the macro will return after kind of inspecting this lambda function. So it will just say, okay, call the function with the current scope. We get the new scope, and then we copy this query builder, and we cast it so that it's query builder with the type parameter tuple scope, intersection, and then whatever fields that we saw this lambda function returns. So yeah, this is kind of the key aspect of the TyQ library. And then there's a lot of to-dos. So these to-dos are not the to-dos for this presentation. These to-dos are things that I guess I wanted to implement in the library, but I never had the time. I guess the one that is like closest to being finished is these prepared queries. So this is basically to say, right now, the whole like SQL generation actually happens at runtime. And the only thing we do at compile time is we generate these types so that we can force it to type check. But actually, what you could also do is like generate the whole SQL in compile time. What you would get from that is simply like performance, right? Like because at compile time you don't really care if it's a bit slower, but then at runtime the query is already prepared. You can just run it. So this is something that can actually be done relatively easily with just maybe a bit of an annoying syntax, but you could actually like create your own macro for every query and then kind of invoke this query building at compile time if you know already what the query is going to be, if it like doesn't depend. Let's say if there's no like if or else based on the user input. If it's just a query with maybe some parameters, then you can invoke that. So soon there could be a nice API for that. Maybe, I guess the most important thing that's missing is like insert, update, delete. So right now, the library only knows how to do select, which I guess is the biggest blocker for anyone to use it in production. All this other stuff, I think it's more like nice to have. Probably not even super difficult to create. So I hope maybe sometime when I have more time, I will actually add that. But yeah, if you're interested in any of these, maybe we can discuss later based on what you want to hear. But now there's a time for advertisement. So I have two things that I wanted to mention. First one is that there are these Lang Talk meetups here at CTU. So if you are interested in programming languages, you should definitely check them out. And I will probably also appear there at some point to maybe talk about Scala in like a more in-depth manner. And then the second advertisement is about a project called Milí Ježíšku, which is like a charity project where you can give a Christmas present to children from orphanages by simply going to this website, miliježíšku.eu. You can just choose whatever like kid you think maybe have some, like the wish that they have is nice. You just fill out a short form and you get the address of the orphanage and you send them the present. It's a project that I did together with another friend of mine who also studied here at FIT. And yeah, we still have a few hundred Christmas wishes there. So if any of you feels like doing a nice thing, I will be really happy if you check it out. And with that, thank you very much for coming. And I would be really happy to answer any questions that you have. We can go more in depth into anything that you're interested.